Good morning, friends. Today I like to discuss the hybrid parameter in common base configuration. The hybrid equation in common base configuration can be obtained by the assumptions of the transistor as it is 4-port device. 4-port device means there are 2 input parameters and 2 output parameters, as 1 and 2 are the input parameters and 3 and 4 are the output parameters terminals. These 4-port device can be considered as the common base configuration, as the base is common, and here it is the input variables are input current, that is emitter current, and voltage, base emitter voltage. The output is IC, collector current and collector base voltage. So amongst this 4-port device, the parameters are input parameters are voltage and current. And these are the output parameters, voltage and current. So on the combination of these two, that is, these are considered to be as independent parameter. Then the mathematical relations between the input and output parameters can be written as VBE is equal to function of input current and output voltage IE and VCB. Output current IC is function of IE and VCB, input current and output voltage. So we consider two variables as independent variable, current and voltage, and two current and voltage are dependent variables. And that's why it is called as hybrid. Hybrid means one voltage and one current mix. With the help of partial differentiation, we have the equation 1 and 2 as d of Vb is equal to del Vb upon del IC E into del IE at constant Vb plus del VBE upon del VCB into d VCB at constant IE. This is equation number 3. Del IC is equal to del IC upon del IE into del IE at constant VCB, and del IC upon del VCB into del VCB at constant current IE. This is equation number 4. These 3 and 4 equations can be written in terms of the hybrid parameter H, and these are d Vb is equal to HIB into B dot DIE plus HRB into dot DVC. This is equation 5. And equation 6 can be written as DIC is equal to HFB into DIE plus HOB DVCB. This is equation 6, where these hybrid parameters, as we have HIB is equal to input impedance at the short circuited, HRB is the reverse voltage gain because this is voltage, input voltage upon output voltage, that's why it is called as the reverse voltage gain, and HFB is delta IC upon delta IB, forward current gain. This is sometimes also known as alpha. HOB is output admittance, delta IC over VCB. So with the help of these equations, we can formulate a matrix equation with the help of this part, and this matrix equation can be considered as the matrix equation of the hybrid equations can be written as, this is d of b be, d of ic is equal to, this is h I b h f b h r b h o b, and multiply with d I e with d v c b. This is the equation number 7. This is the hybrid equation. On the basis of the hybrid equation, we can trace the equivalent circuit of CV configuration. This is given as dVBE is equal to HIB into DIE plus HRB into DVCB. So this is the one voltage. Here it is the second voltage, V1 and V2, and this is the sum. So these are the linear sum of the voltage. So we can express as this current multiply with the parameter. So that parameter must be a resistance. So this is DIE. This is the voltage drop. This is V1, and this V2. V2 is HRB into DVCB. So this is Kirchhoff's voltage law. Kirchhoff voltage law. The other part of the hybrid equation is DIC is equal to HFB into DIE plus HOB into DVCB. So this one is again sum of two currents. This is current I1 and this is current I2. So the current I1, I2 as HFB into DIE, and here HOB into DVC, and this is the DIC. This current and this current, these are the two currents part, I1, I2, and these are connected here. So this is Kirchhoff current law. Kirchhoff's current law. So this is the voltage source, this is the current source. The hybrid part is, and we are connecting this one is, So this is the equivalent circuit of CD configuration. This is the equivalent configuration of CD configuration circuit. The other part, that is, we have to compare with the common base to common emitter circuit. We have to do some mathematical expression in order to get this one is as the total current and the total voltage. The total current and the total voltage can be summed up with the given formulations, and these formulations are written as, let us see the next part of this is from the CE configuration. The CE configuration, the current gain AI can be written as AI is equal to delta IC upon delta IB. And this 1 upon delta IB, delta IC is HFE DIB plus HOE into DVCE. So this is HFE into del IB upon del IB plus HOE DVCE upon DIB. This is nothing but this is del IB. This is del IB. So what we have, AI is equal to HFE plus HOE into del VCE upon del IB. We know that del VCE is equal to minus RL into IC, del IC. So putting this value, we have HFE plus HOE into RL into del IC upon del IB. This is nothing but HFE minus HOE into A into RL, AI, because AI is equal to del IC upon del IB. This is AI. So AI plus AI O HOE RL is equal to HFE. So AI is equal to HFE divided by 1 plus HOE RL. This is the current gain. This is a very important equation, and we will use for the further discussions. Comparison of CE and CB hybrid parameters as this is CE, this is CB, HIE, HFE, HRE, HOE. These are the HI parameter. So HI is equal to HFB upon 1 plus HFB. This HFE is beta. So this is HIB, HFB 1 minus HFB, 1 minus HFB, because we will discuss just after. HRE, this HRE is HIB into HOB upon 1 plus HFB minus HRB, 1 minus, this is this minus HRB, this factor. And this HOE is 1 plus, this is HOB 1 plus HFB. So these are the comparison. So this simple equation gives the concept that is beta is equal to alpha minus 1 minus alpha. That is beta is current gain in CE configuration, while alpha is current gain in CV configuration. So these two variables are already in applications, and the rest of the variables are already given. Now the next part is to have this equation, the transfer characteristic, the plot, the hybrid parameters can also be determined from the various characteristics in CE configuration. These are given as, suppose this is the voltage and this is the IC current, here we CE. So this is the output characteristic, and this output characteristic can be plotted. This IB is equal to 0 and this is IB is not equal to 0. So here IB will increase. Now this delta IC upon delta VCE is at constant IB is HOE, that is admittance. Admittance, that is admittance. Admittance in output circuit. Output circuit. This is the IC. If we consider this IB, so here is the current. This is VCE at constant. This is current transfer characteristic. Current transfer characteristics, and the coefficient, that is IC upon IB is HFE, that is forward current gain. Forward current gain, this is beta. This is beta. If this voltage is considered as B basis BEC, so this one is something. This one is something like VCE and delta VBE upon delta IB. Delta IB is input impedance. This is input impedance, and it is input characteristic. Input characteristics. Here it is VCE and VCB. So these are something like this. Again, there is a IB. So this delta VB upon delta VCE is HRE, that is reverse voltage gain, reverse voltage gain, and this is termed as voltage transfer characteristic. Voltage transfer characteristic. So in this way, what we have the four quadrant, and from these four quadrant we have the four parameters. These four parameters can be, if we indicate symbolically, so this is HOE, this is HRE, this is HFE, and this is HIE. These are the four hybrid parameters from the characteristics. So this one is a good way to express the hybrid parameters from the given characteristic curves. So these are the things that is given. Now we have to think about some example, simple example. That is, take example 1. Example 1 is calculate the hybrid parameters of the given circuit. The circuit given is, suppose this one is a impedance Z1, that is 40 ohm, and here it is another Z2, and this Z2 is given as the value of 20 ohm, 20 ohm. So find out the hybrid parameters, that is H11, H12, H21, H22. So solution. First, H11 is the input impedance when the output is short circuited. Output is short circuit. So let us make it. How to short? Suppose this is Z1, this is Z1, here it is Z2, and this is the terminal, this is the terminal, and this terminal is short circuit. Short circuit means current flow through it, and no current flow in Z2. Thus the input impedance is Z1, that is H11, this is 40 ohm, so this H1 is 40 ohm. This one is the first point. Now when we make the current flow, the voltage across, if it is connected with the respect to voltage, so the second part is when current I1, this current is I1 flow into the box, into the circuit, then this current goes as Z2, here it is open, so this is I1, this is I2, I1 is equal to I2, so the ratio H21 is equal to I2 upon I1 with minus direction, that is -1, so H2 is equal to -1. Third point is the voltage drop. That is I1 Z1 is equal to I2 Z2. I1 Z1 is equal to I2 Z2. So that is, this implies V1 is equal to V2. So H12 means reverse voltage gain. V1 upon V2, that is 1. Here it is 1. The fourth is admittance. Admittance, that is HOE is equal to 1 upon Z2, that is 1 upon 20 ohm. So this is 0.05 mu. So this is 0.05 mu. So this one is the simple way to express the current. If we change this slight change in this example, so we can consider the example. This is example 2 as this the various parameters. We consider the example 2. So for this example 2, let us see the other part. For example 2, we consider another impedance, another impedance in this way. This one is considered as a, Z3. This is Z3, this is Z2. Z2 is equal to 15 ohm. This is the 15 ohm resistance. And this Z2 is 20 ohm resistance. And this is 10 ohm resistance. 10 ohm resistance. So in this resistance, the first is input impedance H11. So for this we have to short circuit it. This is short circuited. So this is Z2, this is Z3, this is Z1. This short circuited gives the Z. Z is equal to Z1 plus Z2 parallel to Z3. Z2 and Z3 are parallel. These resistances are parallel, and this parallel resistance is added to the case. So what is the value? This is 10 ohm, and this parallel Z1, Z2, that is Z2 is 15 ohm. Here it is 20 ohm divided by 15 plus 20. So this value is 10 plus 8.57, and this is 18.57. So this is 18.57. And this one is the first part of the calculation. Now, when the other part, if it is taking the current, this current is I1, this current is I1, and this current flow here it is I2, and this current is here flow I3, I1, I2. So find I1 is equal to I2 plus I3. This I2 plus I3. So when this things is happen, then what the potential drop if it is making parallel, the potential drop across the impedances Z2 and Z3 are same, that is I2 Z2 is equal to I3 Z3. This gives the ratio I2 upon I3 is Z3 upon Z2, and this Z3 is 20, this is 20 upon 15, so this is 4 by 3, this is 4 by 3. So we can have this I3 is equal to 3 by 4. So I1 is equal to I2 plus this I3, and this I3 is 3 by 4 I2. I3 is this gives the I3 is 3 by 4 of I2. So this is 4 by 7 I2. So the second point, and this point is H21, that is I2 upon I1 is 7 by 4. I2 upon I1 is 7 by 4. So this one is the value of 7 by 4. That is 7 by 4 is nothing but 1.4. So this is 1.4. Now third point is by making open the input, the voltage drop in input is V1, that is V2 upon Z2 plus Z3 into Z2. That is V2 into this Z3. Z3 is 20 upon this is 15 plus 20. So this is 20 by 35 V2. This is 35 V2. So in this case, if we calculate the reverse voltage gain, that is H12, thus H12 is equal to V1 upon V2. That is 20 upon this 20 upon 35. So it is 0.57. This is 0.57. Now H22 is 1 upon the output impedance, and this 1 upon output impedance when the input is open. So this is nothing but Z2 plus Z3, that is 1 upon 15 plus 20, that is 1 upon 35, and this 1 upon 35 is nothing but, this is nothing but 0.028. So H22 is this way. So in this way we can have this you can have this various hybrid parameter, and this is the answer. So this is all about the examples. We have discussed the common base configuration hybrid circuit and compared with the common integer hybrid circuits, and the hybrid parameters from the various characteristic curves, and few examples through the circuit components how to calculate the hybrid parameters from the given uh, concept. So this is all about the hybrid parameters in common base and related part. Thank you.